So the next test that we're going to be doing is we're going to be determining the melting point and freezing point of the biodiesel. First, we're going to determine the freezing point. What we have in the large beaker is a mixture of water, ice, and rock salt, more commonly known as ice cream salt. And we're going to place our biodiesel with the temperature probe in it in this ice, rock salt, and water mixture. So right now our temperature is showing to be about 22.9 degrees Celsius initially. I'm going to hit the green, I'm going to click the green collect button, and I'm going to start collecting data every minute. So every minute we're going to get a temperature reading. So our starting temperature, our diesel is definitely liquid. So at each temperature reading, and we're going to get one reading each minute, we not only want to note the temperature and the time, but we also want to note whether or not our diesel is in a solid state or a liquid state. So of course we're starting off in the liquid state, and we want to therefore stop collecting data when our biodiesel has frozen. It's in a total solid state. So we can see that we've collected our second data point. The temperature has dropped greatly, 13.9 degrees. And we still have liquid. And you can see that not only are we collecting temperature data each minute, we're also graphing our data with temperature on the y-axis and time in minutes on the x-axis. We've got our third temperature at minute number 3, 11.6 degrees Celsius. And I'm starting to feel that my biodiesel is now gel-like. It's no longer a liquid. I would say it's a solid liquid mixture, kind of like Jell-O. So we can say that it's a mixture of solid and liquid. It's very gel-like. And it's very hard for me to move the temperature probe in it now. We have a fourth temperature reading of 7.8 degrees Celsius. And now I would say it's still a mixture of solid and liquid, but I would say now we've got more solid than liquid. And so just to lift it up just for a little bit, you can kind of see that it's really mostly solid at this point, but there's still a little bit of liquid left in it. So at 7.8 degrees Celsius, that's our 4-minute temperature, we could say it's mostly solid. So you can see that we've seen a spike in our temperature. See, our ice is not melting. And there it's gone back down. So now we got a reading of 6.1 degrees Celsius. And we've got all solid. See, I can pick my temperature probe up and it's totally stuck in my biodiesel because we've got all solid at 6.1 degrees. So at 6.1 degrees, our 6 temperature reading, at our 6-minute mark, we have all solid. We'll take a couple of more readings to see if it goes lower or if it starts to stabilize or flatten out. Then we'll know that we're pretty much at our freezing point. Okay, it's still going down, 4.3 degrees. That's our 7-minute mark, and definitely solid. So at 4.3 degrees, it's solid. Our 8-minute temperature reading is 3 degrees Celsius, and we've got solid. So that 9.8 degree spike, that was due to the mixing. And so I mixed around the ice and the rock salt a little bit more, and that got us back on the right track. So that 9.8 degree mark, even though we were still at a mixture of liquid and solid, that temperature shouldn't have spiked that high. It should have gone down a little bit more, below 7.8, but that was a little experimental error on my part. I turned off the stir plate mechanism. So I realized now, hey, I need to keep this stirring. Okay, we're still going down, 2.2. And of course, we've got solid. The probe is really stuck in there now, so I can lift it and my probe stays in there because my probe is frozen inside of the biodiesel now. So we definitely have all solid at this point. And our temperature is still going down. And so, if it wasn't for that little 9.8 degree spike there, there's our little spike in our graph, we would have had a pretty smooth curve other than that little spike there. But we can kind of ignore that. That's not really the part that we're interested in. We're interested in when the curve starts to flatten out and when our temperature stops changing. So when our temperature stops changing, that final temperature is going to be our freezing point for our biodiesel. So we're still going down a little bit. We're at 1.6. So to determine the melting point, once we're done determining the freezing point, all we're going to do is take the test tube out of the rock salt ice mixture. We're going to just place it in the test tube rack at room temperature. We're going to leave the probe in, and then we're going to start a new graph And this time we'll be seeing our temperature start at a very low temperature and then increase to room temperature. And then we're going to note the point at where all of the solid biodiesel turns back into a liquid. And that's going to be our melting point. Okay, we've got another reading, 1.3 degrees Celsius. It's still solid, of course. So notice that our temperature differences are getting smaller. So we're getting very close to our freezing point now. And notice our curve. It's starting to flatten out. So let's see what our next couple of temperature readings are. We may be very, very close to the freezing point. Okay, we're at 1.1. So again, our temperature differences are getting smaller and smaller. The last couple of readings, we had 2.2, then we went down to 1.6. That's a 0.6 degree difference. Then 1.6 to 1.3. That's a 0.3 degree difference. And then 1.3 to 1.1, that's a 0.2 degrees Celsius difference. So we're seeing our curve start to flatten out. So it's very important for fuel, especially that's used for transportation purposes, to have a very, very low freezing point. So therefore, if you're in a climate where it dips down to minus 20 degrees, like in Minnesota or North Dakota in the wintertime, you want to be using a fuel that's not going to freeze at 0 degrees Celsius. Or, well, I correct that, at 0 degrees Fahrenheit. No, I said it right the first time. You don't want it to freeze at 0 degrees Celsius. You want it to have a lower freezing point than water, basically. So we got another reading at 1. So this time our difference in temperature was 0.1 degrees Celsius. So our 13-minute mark, we're at 1 degree Celsius, and of course we're still in the solid state. So we know from this point we have solid biodiesel. We're just trying to narrow down the melting point. We're going to take another reading. We're at 0.9. So you can see now that our change in temperature is getting very, very small, within 0.1 degrees Celsius differences. So we'll take another 1 or 2 readings, and then we will settle on that final temperature reading as our freezing point. And we're still at 0.9. So yay, we are finished with determining the freezing point of our biodiesel. It is 0.9 degrees Celsius.